Today's lesson is going to be about number classification. That's just being able to know what type of number a number is, if that makes sense. So, or maybe we could even think of it as what numbers go in what number sets. So number classification or number sets. So let's start with the very most basic number set, the one that we begin to learn as an infant or a child. They're called the natural numbers or the counting numbers, and that's exactly what they sound like. It's 1, 2, 3, 4, and it continues on up to infinity. As long as the number has no decimal or fractions, they're not negatives, and it starts with the first one being 1, and then just progresses 2, 3, 4, 5, 6, 7, 8. Those are the natural or the counting numbers. Now, those natural or counting numbers, if we attach one more number to them, we give it a whole new name. If we attach the number 0 and then also include 1, 2, 3, 4, and so forth, we call those the whole numbers. The whole numbers. So the set that contains not only the counting numbers, but 0 as well is the whole numbers. So if, for instance, someone said, what type of number is 3? You would say not only is it a natural or counting number, it's also a whole number. Then on top of the 0 and then the 1, 2, 3, 4, the next set we're gonna keep those numbers in our set, but we're going to attach negative numbers. So we're going to come in from negative infinity, and we're going to include -4, -3, -2, -1, and still we're including 0, 1, 2, 3, 4, and so forth. Those are called the integers. The integers. So again, now if someone gave you that number 3, again, you'd say, oh, that's a natural counting number, but it's also a whole number, which is also a integer. But if someone gave you -2 and asked you what type of number -2 is, you'd say it's an integer, but you wouldn't call it a whole number. Whole numbers are never negative. You wouldn't call it a natural number or a counting number because those start at 1 and go up through the positive whole numbers. So the integers include the negatives, but 3 is an integer. -3 is an integer, but 3 being a whole number is not, or sorry, -3 being an integer is not necessarily a whole number. Now we're going to include one more type of number. So we're keeping all these in our set, but we're going to include fractions, 1/2, 1/3. We're going to include a lot of decimals, because remember, 1/2 can be written as 0.5. 1/3 can be written as 0.3 repeating. So remember that little bar above the 3 means that 3 goes on and on forever. So any number that can be represented as a fraction of 2 integers. So I want to make sure I make that clear. A fraction of 2 integers, we call that a rational number. And by the way, all these numbers in these smaller sets are considered rational. We can represent 4 as 4 over 1, but we can't represent 1/2 as an integer or a whole number or a counting number. So there are a bunch of rational numbers that are not integers, but all integers are rational. There are a bunch of integers that are not whole numbers, but all whole numbers are integers. There is one whole number that is not a natural or counting number, but all natural or counting numbers are whole numbers and integers and rational. So it expands out. So now we have all these numbers up through the rationals. Now we're going to include a totally separate set of numbers, totally separate from all these. So it doesn't include any of these. And we're going to call those the irrational numbers. The irrational numbers are decimals that never repeat, meaning the decimal portion never repeats, and it continues, it's continuous or continues forever. Pi is one of the most popular or famous irrational numbers. Square roots of non-perfect squares are considered irrational. Square root of 5, square root of 20. All these because, again, the most important thing is that the decimal, if you were to write out the decimal, 3.141592653 ... it keeps going, and it never, ever repeats. So if they give you pi, or a number that includes pi, or they square root a number that isn't a perfect square. Now, what I mean by a perfect square is if I gave you the square root of 9, that's actually just 3. So don't confuse, just because you see a square root, you assume it's irrational. Make sure it's not a perfect square. We talked about that in a previous lesson. So for this lesson, I would recommend writing this diagram down. So when you work on number sets, if they give you a 1/3 or a 0.3 repeating, you know that's a rational number. If they give you pi or the square root of 5, you know that's irrational. If they give you 4, you know that's not only a natural or counting number, you know it's a whole number. You also know it's an integer, and you also know it's a rational. By the way, one last thing, both these sets put together, the irrationals and the rationals, if we put it all together, all these numbers together, they are called the real numbers. And we call them the real numbers because every single one can go on a number line. -1, -2, all these numbers. If here's 3, pi is going to be in here somewhere if 4 is there, right? Square root of 2 will be here somewhere, square root of 2. So, and 1/2 is right here, 1/2. And all these numbers are the real numbers. They all go on the number line or can be found on the number line. And like I said, if you need to, just write this diagram down and you'll be able to classify your numbers.